Hi everyone! In this video, I'm going to make the fastest line follower robot using Arduino Nano and PID control algorithm. This robot runs at 600 RPM and can solve 90 degree, 60 degree, and 45 degree turns. If you're new to this channel, please subscribe and turn on the bell icon to get the notification for new videos. We need a 12 by 10 cm Vero board, and 20 gear motor of 600 RPM, and 20 wheels, and 20 motor mount bracket, and 20 ball caster, 6 channel line sensor array. I've shown how to make this line sensor in my previous video. Please explore this video. You can make it yourself. L298 and motor driver, buck converter, boost converter, 5mm LED, push button, female header pin, T-connector, battery holder, and some wires. So, I've designed the model of the robot in 𝐀𝐬𝐥𝐚𝐦. This is the look of my robot. I printed the design on paper, and now I'm transferring it into Vero board. I've made the necessary holes to place components in the Vero board. I've soldered the necessary wires with the motor driver and placing it on the Vero board. Placing the boost converter module on the right side. Here I'm using a boost converter to provide a constant 12 volt in the motor driver. If the input voltage isn't constant, then the robot's speed will be reduced by the reduction of battery charge. And the buck converter is used to provide a constant 5 volt into Arduino and sensor. And buck converter module on the left of the motor driver. Now I'm placing Arduino Nano in the Vero board using a female header pin and soldering it in Vero board. You can detach Arduino whenever you want. Now placing the male T-connector and a locker switch in the Vero board. Here I'm using a T-connector so that I can use any battery. Connecting buck and boost converter's power input terminal with T connector through locker switch. Connecting motor control pin with Arduino, as like table. Now I'm attaching the 6-channel line sensor array in the front of the robot. Placing push button and status LED lights, as like table. Connecting the sensor's signal out pin with Arduino, as like table. Now attaching N20 gear motors by using motor mount brackets. Battery holding with female T connector. And placing it in the back of the robot. Attaching ball caster just behind the sensor. Set the output voltage of the boost converter at 12 volts and give it to the motor driver input. Then buck converter at 5 volts and give to Arduino and IR sensor. Attaching wheels. So everything is done. Let's come to the coding part. First, define the pin for the motor driver. Declared necessary variable for the line follow algorithm. Defines pin for push button and LED. In the setup function, motor pins are output. Button pins are input. And LED pins are output. In the void loop, LED 13 will be on. Then the button status function is called and the state of the button is stored. If button 1 is pressed, then LED 13 will be low and LED 12 will blink 4 times, then the robot will start to follow the line using PID control. If button 2 is pressed, then LED 13 will be low and both motors will run forward for 3 seconds to check if the robot going in straight or not. This is for checking the motor's speed and direction. If button 4 is pressed, then it will the sensor values in the serial monitor. This time LED 12 will be blinking. If the button 3 is pressed, then the robot will stay in stop mode. And LED 13 will be high. Now upload the code. I've pressed button 4 and it's showing the sensor value. Then press button 3 to bring the robot in stop mode. Then I press button 2 to check the motor direction. Then press button 1 to start following the line. Let's see the result now.